Mrs. Students, in our last lecture we have studied about graphical representation of pair of linear equations. I have written general form of linear equations. Two equations I have written. In case we draw lines for these two equations, straight lines on the same graph, we have seen that we can have intersecting lines, we can have parallel lines, or we may get coincident lines. In case intersecting lines are there, that means lines are cutting each other at a single point, that means we can say we have a unique solution for these two equations. In case lines are parallel, that means lines are not intersecting each other, lines are not meeting each other at any point, so we don't have solution. In case coincident lines, that means both the lines are cutting each other at many points, that means we have many solutions. In case we say unique solution means solution exists, that means solution is consistent, it is there. In case of many solutions also we say it is consistent solution, but in case we have no solution means inconsistent. Without drawing graph, if we want to check whether the solutions are unique, no solution or many solutions, then if we compare the ratios A1 upon A2, B1 upon B2 and C1 upon C2, in that case if we get A1 upon A2 not equal to B1 over B2, then we will be having unique solution and lines are intersecting. In case A1 over A2 comes equal to B1 over B2 but not equal to C1 over C2. A1 over A2 equals to B1 over B2 but not equals to C1 over C2, that means these equations have no solution and lines will be parallel. But in case all the three ratios A1 over A2 equals to B1 over B2 equals to C1 over C2, in that case we will be saying the given equations have many solutions and lines are coincident lines. But for example, like a child is not comfortable with the graphical method. So a question comes to the mind, do we have any algebraic method also? Yes, we have different algebraic methods also for solving or for getting solution for linear equations. These methods are substitution method, elimination method, cross multiplication method and then reducible method. In today's lecture, I am going to explain first method that I am saying, substitution method. For explanation of substitution method, I have taken an example. In this example, I have taken two equations, 7x minus 5y equals to 10 and x plus 2y equals to 3. As the name suggests, substitution. So here, we just write one variable in terms of the other variable and then put or substitute that value in other equation. For say, from equation number 2, if I rearrange the terms, I can write x as 3 minus 2y. That will be third equation. Now if I substitute this value of x in equation number 1, from equation number 2 I have obtained this relation. Now substitute equation number 3 in equation number 1. So what will be getting? 7x. In place of x, we will be substituting this value. In place of x, it comes 3 minus 2y. Then minus 5y is already there, equals to 2. Now I will be opening this bracket and we will be getting 7 3s are 21. 7 2s are 14. 21 minus 14y minus 5y is already there, equals to 2. Now minus 14 and minus 5, minus 19y equals to 2. This 21 will be shifted to this side. It will be minus 19y equals to minus 19. So, just by cutting we will be getting y equals to 1. Minus and 19 both get cancelled. We got y equals to 1. Now this value of y will be substituting in equation number 3. So putting y equals to 1 in equation number 3. According to equation number 3 we have x is equal to 3 minus 2y. Y we have obtained 1. So we will be substituting this y value as 1. 3 minus 2 into 1. So x equals to 3 minus 2. So x equals to 1. So using substitution method, we have obtained the value of x as 1 and y as 1. One more example. Here we have to solve 0.2x plus 0.3y equals to 1.3. 0.4x plus 0.5y equals to 2.3. We have to find the value of x and y using substitution method. First of all, in this case, we can remove decimals. So, it will be 2 upon 10 plus 3 upon 10 and 13 upon 10. So, if we take LCM, we will be getting 10 on this side. So, we will be having 2x plus 3y upon 10 equals to 13 upon 10. 10 and 10, removing from both sides, we will be having 2x plus 3y equals to 13. Now let this be the first equation. In same way, if we remove decimal here, we will be getting 4x plus 5y equals to 23. Let it be second equation. Now it is given that we have to solve these equations using substitution method. Now select any of the equations. Suppose I am taking first equation. From first equation, I will be getting the value of one variable, say x. So I am having 2x equals to 13 minus 3y. I have shifted 3y to that side. Now I will be shifting this 2. Will be going as denominator. So value of x I have obtained as 13 minus 3y upon 2. Let it be third equation. I will be substituting this value of x in equation number 2 because variable x I have obtained from equation number 1. So substitution will be done in equation number 2. So substituting substitution of value of x in equation number 2. 4. Equation number 2 we have 4 into x. In place of x, 13 minus 3y upon 2 will come. Then plus 5y equals to 23. Now here, cancellation can be done. 2 and this 2 will go inside. We will be having 26 minus 6y plus 5y equals to 23. Minus 6 and plus 5 minus y and 26 going to that side. 23 minus 26 will be minus 3. So y comes out to be 3. Now this value of y will be putting in equation number 3. Put y equals to 3 in equation number 3. We will be getting x as x equals to 13 minus 3. In place of y, we will be substituting 3 upon 2. So this is 13, 3 3s are 9 upon 2, x 4 upon 2, that means 2. So we have obtained the value of both the variables y as 3 and x as 2 using substitution method.